Oh, good day, ladies and gentlemen. Thank you for joining me on this webinar today. So, no, it's a bit of a mouthful, but in this webinar that we're going to be looking at is basically retopolizing the scan data in 3ds Max, Meshmixer as an alternative, or Fusion 360 modeling. Thank you. So, a little bit of an introduction first. My name is Quinn Kennedy. I'm an application engineer here at Micrographics, Durban branch. I'll get into that a little bit later. My email address on the screen if you want to send me a mail, have a chat, etc. about something I've done. I'm primarily focused more in the plant field, but I do quite a few other different things, a little bit of nifty bits and pieces, like for instance, as we're going to be looking at, actually using scan data. Now, if you've ever used scan data probably on large scale, like plant size, we use it quite often. We can kind of capture an as-is state of a place and know that wherever we're routing pipes, we can do it with the knowledge that whatever we've captured and whatever we're going to route is going to work in real life. Now, that's normally on the big scale of things, but today I'm going to focus on a few, like a small scale of things, more accurate scale of in the millimeter range, if not less. So, carrying on. So a bit about our agenda as to what we're going to be looking at. So introduction, currently where we are at the moment. Next is going to be our scan data and issues in Fusion 360, which we are going to have. I've actually personally used this workflow. I'm going to show you a bit, show you the original workflow I had, and then as the next section states, using 3ds Max with the latest update to retopologies, tri-mesh to quad mesh. And that is a big thing that I've got over here. Okay, then Autodesk Meshmixer as an alternative, is it? Inserting retop mesh into Fusion 360 to be used. Little bit of a bonus thing as to how we can make a Voronoi 3D model. Then lastly, some summary and Q&A. Yep, with that, we're moving swiftly along. So, firstly, scan data and issues in Fusion 360. And also, one thing I just want to state here is I'm not going to do a death by PowerPoint. I am not that type of person. I really don't like that. So a lot of the stuff I'm going to be doing is on the fly stuff. So just bear with me for a little bit. But a few things, yeah, I'm going to jump to some slides so that you can see some of the notes. Now, in here, I've actually got my view on this arm that has been scanned. Now, one of the things you'll notice with these things is that the mesh density is very, very high. So you can see lots of little triangles everywhere. And also, that being said, they are triangles, which might not sound like an issue, but I'll show you why this comes into an issue. So in here, I have got my raw scan that's been brought. It's not just a raw scan, to be honest with you. What's happened is this has been already created into a mesh via the software. So this would be kind of a base starting level. So it's not a point cloud. You'd have to collapse a point cloud into some form of mesh first for this. So looking at this, we've got this mesh. Very nice looking mesh. Now we're going to see, okay, well, how can we work with this mesh? Firstly, I'm going to jump to my visual style, and let's say I'm going to go to a wireframe view. So just go to display settings, visual styles, and wireframe. You can also use control 4, 5, 6, etc. to jump to those if you really wanted to. But the reason why I'm doing this is so I can actually take a look and interrogate the mesh itself. As you can see, very, very dense. This is going to be very heavy on machines and processing power. Denser the mesh, heavier, of course. Now, the problem comes here is how do we use this? Now, as many of you may be aware already, is that if we select a mesh and you right-click, you can go convert. Otherwise, if you go into mesh or one of the other forms over here, you can use the conversion tools inside there. I normally use the right-click method because I find it faster. But I right-click on the mesh, and if we go, convert, you can see, oh, wait, we've got convert. And if you look, T-spline, it's not a T-spline. B-rep, basically think of a solid. And quad mesh to T-spline. But here's where the crux of the matter is that it's a quad mesh. We currently have a tri-mesh. So all the little faces are triangles, which makes it a problem. If you even try and use this tool, so you can see I've got it currently selected. I've got my solid selected, also not my solid, my mesh. It's just saying, okay, make it into a new body. And if I go okay, it's going to complain bitterly because it can't do that. Why? Because too long didn't read. Basically, all of it is triangles, is 0 quads, 0 polygons. So quads being 4 sides, triangles being 3 sides or 3 points, polygons multiple. Well, greater than 4. Okay, so how do we fix this? Well, it used to be pretty problematic in that we had to do a whole host of jumping around, etc. And I personally used things like, for instance, Meshmixer and that to reduce. Though you can also use the built-in tools within Fusion 360 if you jump into the Mesh tab, and you can use Reduce here if you've got everything selected, and then reduce it by a specific percentage. And it actually does work quite well. But as you can see, even with reducing that, it gets there. But the problem is that's just reducing it. And I'll go on about that a little bit more about how we could use that later. But for now, I wanted to show you guys the new easy way how we can do this. And what that involves is that you have to have access to 3ds Max in order to do this, because 3ds Max recently updated and released a very interesting little modifier. So if I come back here in 3ds Max, I've got the exact same model open. So if you had this in Fusion 360, you'd have to download this to your local machine or wherever, and then open it up in 3ds Max. I'm not going to cover that because it's the basic side. It's basically a case of file, open the file. Now in here, I have got the scan. And as you can see, I've got it open in my main viewport here. And if I pan around, you can see how dense this mesh is. They're the exact same model. Now, the trick of this is to do is we select the actual model itself. We can then go to our modifier. And then you'll see in my modifier, I've already got a modifier retop. Now, I'm just going to delete that off because at the moment it's actually not active and show you when I put it back on. So if I select it, pro tip, just type in RET for retop and it'll jump there, or otherwise, if you really wanted to, you could just scroll all the way down the list and select retop. Click it, and once clicked, it'll add the retopology tool here. Now, for the sake of this demonstration, I have to also warn you though that this does take a lot of resources. You're going to need something a little bit more, well, with a little bit more horsepower when it comes to computing, because these things can take a while, quite a while. And also, by doing a retopology, remember you are going to be changing the surface. If you change the surface, the accuracy will be slightly off. It will deviate slightly from the original. Not much, maybe not even a measurable amount in most cases, but it is going to deviate. So be aware of this when you're trying to do very, very fine accuracy. Sometimes, in order to make our lives easier and to do certain things, we're going to have to sacrifice a little bit of accuracy in this case. But as I said, generally it is not much, especially when we're doing something very organic like what I'm about to show you here. So, like before I went off on that tangent, one thing you have to be aware of is that this is going to take a while if I was to try and perform this retop now. Normally what we'd do is we'd go retop, and then we would specify in retopology quadriflow, and then give it a face count. For this demonstration, I've already got a model that I've already done half of this to. So all I've done with this specific one is I've already reduced the faces significantly, the triangles. It doesn't look like it, but it actually has been reduced just to the point that we can work with it. This will be the exact same workflow as with a complete raw mesh. It's just this has been done so for the demonstration purposes. So what we do is I'm going to select the mesh again. I'm going to add my retop modifier, retopology. I'm going to change my retopology to quadriflow. And then I'm going to tell it, okay, I want you to go to 10,000 face count. Sounds like a lot, is a lot, but it actually isn't. Now, when we hit compute, it's going to be thinking. It's going to be thinking. And this may take a while. Like I said, depending on your system. Now, I'm running quite a beefy system, so it does it pretty fast, but depending on what you've got, this can take a while. Now, what was really interesting is notice that all of a sudden, it's crunched down all of those triangulated faces into our lovely quad faces. Now, you'll probably have noticed that when we're looking at things like this, these little edges over here, that they're slightly off. You've got slight sharp corners, etc. I mean, if you wanted to, you could add some things like a smoother modifier if you really wanted to. But for this demonstration or what we're busy with, this is fine. But I also wanted to point out that this is where you'll start seeing more inaccuracies start coming in. If you want it closer to the original form, up the face count. The higher your face count, the more accurate it's going to be, but the heavier it's going to be on the system. The reason why I've done this specific model, as I said, is for the demonstration, in that it's going to be fast enough to use, but still give us an accurate overview on the in the end results. So this is basically what we're after. Once we've done that, you can go File, and we can export this out. And what we're going to be looking at is you want to export it out into any other files that can support a quad mesh. Normally what I use is just a normal OBJ, just because in case I'm old school with this. Export an OBJ out, select whichever one you want. As you can see, I've done this a few times when I was prepping for this. So arm scan, quad mesh. And then give it a number and save. It's going to ask you a lot of these things. If you don't know what these are going on about, don't worry too much about it. The main thing you want to be wary of is it saying quads? Export. Going to export all of that. Like I said, depending on your machine, this may take a little while. And I'm going to go done. Cool. Once it's done, you can then go back into, well, whichever program you're using. So for an instance, I'm doing this demonstration for Fusion 360. Going to go back into Fusion 360. You're going to go upload, select, or you can drag and drop the file if you want. Select the file. Now I've already got this on my desktop. I'm going to go date modified. And there's my new file. And I'm going to go open. Now, what this is going to do is it's going to ask us, okay, cool. Do we want to upload that? Yes. And upload. As you can see, I've had these other two that was uploaded just for quick testing this morning to make sure everything is working. And it's doing its job. It's going up into the cloud. Now, as I said, this can take a while. This is actually more dependent on your internet connection than anything else. Give me 1 second. Okay. Now, jumping back to our slides. So we've already gone through this. We've gone through exporting into the quad mesh. But now what we'll see is when you've imported it, close, it's going to be sitting here in our list. And we can open it up. And we've got now a quad mesh. So this is pretty cool. But now you may say, but Quinn, now that you've got a quad mesh, now remember that conversion tool. Now you can select it, the mesh that we've just made. And if you look at the bodies, you can see it's a mesh. You can right click and you can say convert. And we're going to convert our quad mesh to Tspline and go OK. Now we've got an interesting thing here. I'm going to switch my display settings so that we can see visual style. Let's go shaded edges visible. Now we've actually got this interesting surface, or should I say our actual form that we're using, not a surface. Now, you may be saying, okay, well, what's really the use of this? How is this useful to us? Well, now we can actually do some interesting modifications and playing around with this, because with meshes, we're limited in some ways as to how we can work with it in a workflow that's actually going to benefit us. Or otherwise, it could just be very tricky. Working with meshes, if you've got experience in it, you know it, depending on your skill level, it can give you strange results. It can be difficult to work through. But forms, though, solids, is another story. We can do a lot of more interesting things with it. Such as, when we've got it over here, what we can also do is run things like modifiers. Well, not modifiers, slight modifications. Such as, now that I've got my base mesh, we can go and we can say, okay, cool. Well, what about if we just went and said, okay, let us go and use our modifier, and we're going to say thicken, and I'm going to go, okay, I'm going to select this entire thing, and I'm just going to say, okay, let's thicken it by 10. This demo was slightly off. It was 1 decimal place off. So this 10 would normally be probably 1 in normal cases. Thicken type, sharp, soft, no edge. So what I'm going to say is actually no edge. The reason for this being is what I'm creating here is something like a cast or a glove or something, and this 10 millimeter would actually be the offset. It's not actually 10, it's just because, like I said, the demo set was a little bit large. So this would probably be normally a 1 millimeter offset instead. And this no edge would give us that 1 millimeter air gap, or 10 in this case. And I'm going to go, okay. Maybe it's for a statue, I don't know. Now we wait 1 eternity for it to crunch. It's going to crunch this. And, there we go. Doesn't look like it's done much, but watch what happens if we switch it on and off. You can actually see it visually thickens. If I were to go and hit A for alpha on the keyboard, pops up in my appearance tab, and I can go, hey, cool, wait a second. Let's go and assign this something, let's go like colored glass, like heavy blue here, or something like that, so we can see a difference. Then you can actually see through, and you can actually see the original beneath. You could also do some transparency or something like that with it, but going a little bit old school on us now. Okay, so now that we've got our thickened, remember this is still a form and it's just been thickened, so now we've got this almost like a skin around it. Well, we can always take it further from there, and we can then work with it, such as we can run another thicken, and select our main object, and then thicken it again. Maybe this time by a little bit more. So maybe this time I'm going to go 50. And go, okay. Cool. Then what we can also do is we can then use our modifiers, and we can maybe delete sections or remove sections, etc. Now, what I've basically done here, and it's busy thinking because I'm just trying to figure out what to do. You could do it this way. There's plenty of ways how to skin the cat from here on. But basically what I'm showing is that we could create a object and then start modifying it from there. And then what you'd basically be left with is, if I jump back to my main system, there we go. So what you'd be left with is we're going from our raw scan, to our quad flow. I've thickened it on this one. And over here, I have played around. I've actually then basically gone from this system. Sorry, this is before thickening. I've gone from here, I have thickened it, I have trimmed it back a bit, and I've worked around just making it basically neat. I've done exactly what I've shown on this one. All I've done in this one is just done it already. This is all the little playing around and making it neat, etc. It takes a little bit of time to get used to the workflow and working with it. But the cool thing is that this now can actually be then selected, converted, and we can actually convert this to an actual solid. When I hit OK here, it's going to think of it. And then what it's going to do is it's actually going to pop out an actual solid, which is pretty cool. Because then what we can do is we could actually even send this for machining. We could do a whole bunch of things with this thing. We could also do a 3D print, but that, as you probably know, if you've got a watertight mesh, you could do it in any case. But what this gives us the ability to do is it makes it very flexible and easy to work with. In that all we'd have to do is, if we wanted to do any changes, go back to our meshes, or go back to our mesh, go back to our form. You can actually see the workflow as we've progressed. Now, this then would be a cool way as to how you could do a basic modification onto a scan. How we can use our retopology tools from in our 3ds Max, bring it into Fusion, and then work with it from there. But like I was saying previously, is okay, this is all fine and dandy, and maybe this won't apply to a lot of you, but is there any other options? For instance, a lot of people always ask about Meshmixer. Yes, you can, but it's got a slight problem with it, and that being is that it doesn't have the same quadraflow. In other words, what you're going to have to do is you're going to have to use this method that I came up with a while ago. Now, the best you could get to in Meshmixer, if I were to open up Meshmixer, and taking a look at the base. So that's just the file that I already had opened. Oops, no, that's the wrong base. Sorry, I'll get here in a sec. Hang on with me, please. Let's go file, open, and let's open up our. In fact, you know what? Let's do an import. And I'm just going to open up the main one. Okay, what I was asking there basically was a whole bunch of bits and pieces what we're working with. Oops, and my 3D mouse is a little bit incorrectly set up there, so I'm using the keyboard now. Okay, so in Meshmixer, yes, you could do a lot of these things. For instance, if we were to go to Mesh View by going View and going Show Wireframe, you can see the mesh. And then a lot of people would say then, okay, cool, because you can use your selection tools, select the whole thing, and then we could go edit, and we could use our reduce and remesh to work on this, to give similar results as to how we processed it in 3ds Max. But like I said, the biggest problem is it doesn't matter how much you try and process this. Just a bit of a tip, by the way, if you are going to do this, if you remesh, does sometimes take a bit of a while, like I said, depending on your system. And you set your density up over here, you can reduce the density straight. So it's going to reduce the triangulations or triangles by how many ever percentage you set this density. Though, if I remember correctly, the density can only go down to 50% here. If you want to go any more than that, you're going to have to actually use the other function over there, which is the reduce function. Okay, this does take a while, like I said. It's actually taking a little bit longer because I've got quite a few things open. Bearing, etc., etc. There's part of a reason why I'm showing you this now as well, because what I'm going to show you now could actually, oops, sorry, I went the wrong direction on my remesh. I should have gone the other direction. Sorry, on the density. There we go. You can see density -43. I accidentally went right because on the other side you go right. And you'll see that now in a second. But as I said, you can only go to a certain amount. So even at best case scenario, I can only go all the way to 50% and accept. Now, once that's done, you can see all the triangulations. Cool. Now, once I'm done over here, I can then go and say, okay, now I want to actually take it even further. I want to reduce this mesh even further. And then we can use our, selection, select everything. We can then say, okay, edit, and we're going to reduce. And then with the reduction, we can actually reduce it even further. You notice what I mean by going left on this one makes it gives you more triangles. If you go right, gives you less triangles. All the way up until we get this weird block that doesn't do anything. Now, that's what I'm saying is this is basically the maximum you're going to get. And the reason why you'd want to do this is to try and make your mesh more simple so it's lighter and easier to work with. You can also have a few other advantages. But then what you do basically is you say, okay, cool, I'm taking it to a certain point. It's accurate enough for my use. And then go accept. Allow it to do its thing. Then what you do is you can go File, Export, and then you can export it as an OBJ file again. Remember, previously we exported from 3ds Max also as an OBJ file, and you would export it into here and then upload it again into our Fusion 360. So you can do it that way. But the problem is that you will eventually wind up with this exact same problem that you had previously, that you end up with a triangulated mesh, a tri-mesh. So how would we get around? How would we do this before if you don't want to use 3ds Max, or you don't have access to 3ds Max, and you end up with this triangulated mesh? Well, to be completely honest with you, this is the reason why I say that using our Meshmixer may not be the best option, because you can actually do this from a complete standard scan that you get straight off. It's just going to be a little bit more difficult to work with in some cases and not as neat, because the unprocessed mesh can be a little bit messy, to say the least. So you may want to look at maybe reducing in Fusion 360 at the very least. Long story short, if I come back over here, what I've done is I've taken my mesh and I have created forms. So it's just a form. I've gone cylinder and I've created a form over here. And then I have moved it around so that I have got it around my objects. That's all I've done here, nothing special. You might be going, well, Quinn, why are you doing that? I mean, that just looks a bit strange. So in this case over here, I did exactly what I've just shown you by creating this. The only difference being is that due to the time limits of this demonstration, I'm not going to try and get something like that as straight onto here. This section at the back here is been a little bit more finely tuned, that I've gotten a little bit closer. But as you can see, it's still very far off. And to do it even to this section over here at the back is going to be a lot faster than trying to get it that it's skin tight. So how then are we going to work with this? Well, we go modify again. Remember previously we used thicken. Well, in here, there's actually a cool tool that's not very well known, which is called pull. If you use your pull tool, you notice you can see the little vertex on the, or vertices. I'm trying to say vertex and vertices at the same time. So you can see all the little points here, and you can actually see if you hover over them, they highlight. Now watch what happens when I just do a drag selection over all of them. It pulls it to the surface. Go, okay? Now watch this section at the back over here. Modify, So now modify, use the drop down, and I'm going to go pull. I'm going to pull that to the surface. So this is another way that you could use it. Maybe this works for you. Maybe that's all you need to do, meaning you don't have to go the whole 3ds Max route, etc. But it also means that in a lot of cases, you don't have to go the whole route of using the downsizing the mesh. One of the problems that you're going to find if you don't reduce the mesh, though, is that what this is doing is it's actually putting these points down directly to the mesh itself. And if you don't reduce the mesh, it can create weird behavior. Also, the more points that or more control vertices that you've got actually on this form that we've just now constricted and pulled around, so the denser that we make this original thing by adding in more lines, more vertices, the tighter it's going to grab onto the mesh, the better it's going to look, but the heavier it's going to be on the machine. So just be aware of that you can do that. So just once again, that was in our form. We went modify, use the pull command, and then just dragged it over our form. So that can be very powerful by itself. It's not as accurate. It's not going to be nearly as accurate as using the 3ds Max method, in that where we've got a almost flawless surface to surface that it's actually created between the original scan, or should I say the retop section of the scan, to our created piece. So this would be far more accurate and quicker as long as you've got access to your 3ds Max. Otherwise, for the rest of us, you do also have this option here. Not as accurate. Well, should I say it can be quite accurate as well, but it's all about the amount of time that you're wanting to put into it. If you're going to be putting in many, many, many hours into getting this right, then it's up to you. Okay, but now here comes the interesting part of what I was going on about. So if we jump back to our section over here, so we basically have shown us to how we can use 3ds Max to take our original scan, create it into a quad, and then create these lovely things like casts, maybe pieces of clothing. I don't know, up to you to do this. And then also, does Meshmixer work? Yes, it can. Sometimes you can actually do a lot of guys that do 3D printing will use Meshmixer directly like this, and they can do some amazing things. But the problem that I found is time is the big thing. Next thing, now how do we actually use this? How do we actually take it out? Well, you could, like I said, send it to CNC if you really wanted to, I guess, but that would be very difficult to work with. A lot of people would use this for 3D printing. Now, cool thing about this in 3D printing is how then can we make it more interesting, or how can we actually maybe reduce the resource cost by just instead of just using our infill, etc. Well, we can do something that's quite visually interesting, which is called a Voronoi pattern. Now, if you've ever seen a Voronoi, it's basically a very organic looking model that we can do with it. And what we're going to do this Voronoi pattern is use our old friend Meshmixer. So in Meshmixer, oh, by the way, just a bit of a quick tip. If you're wanting to pull things between, if you're wanting to do this, you're going to need to do it in mesh form, unfortunately. So that's a little bit of a funny thing because we're going in this backwards and forwards process. So remember when we had our form and we right-clicked on the form and we went convert, and we converted it to a B-spline. Oh, sorry, not a B-spline, a B-rep. Went OK, and we ended up with this odd-looking body. Believe it or not, this is actually what you require in order to crack it back into a mesh again that we really need. And I found the easiest way to do this actually is create your body and then go File, and just close that. Run one. We're going to go there, and we're going to go Export. Use the drop down. Oh, sorry, probably wrong one. Save as. I thought it was the export. Maybe because I haven't saved. 1 moment. You can also use a 3D printing utility, but basically what we're trying to do is just get out our. Sorry. Been jumping between different programs recently, so my brain is a little bit on the confused side. Export. Ah, yes. Scroll down. When in doubt, scroll down in the menu. It does apparently help. So yes, on our type over here, sorry, that's what I was looking at. If you scroll down at the bottom, one of our last things over here is STL. So with our STL, what it's going to do is it's going to break our mesh back into a triangulated mesh again. So if I went over here and I went, okay, cool, export, it's going to do its exporting again. So remember, we've been doing importing the whole time. Now we've exported it. Now, I've already actually done this because this can take a very long time to export. But I've already done this already, and I've already got one at the bottom here, which is exported STL. So if I go down here to the bottom, I go File, and we're going to go Import. And let's say, there we go. Arm scan workflow exported STL. I'm going to go Open. Yep. Oh, that's why, because I went to Pen. Place. There we go. That's what I should have done. Sorry. So now, if we take a look over here, you can actually see as to how it's going to come out. This is basically the raw export as to what this would have spat out. And as you can see, it's still trying to, in 3ds Max, sorry, not 3ds Max, Fusion 360, it is still trying to spit out this STL. So at the end of the day, you're going to end up with something like this. Number one, it's triangulated. Cool, that's what we actually want for this. Weirdly enough, I know we're jumping around. We took it from a triangulated mesh into a quad mesh and then back again. And it's a lot of bouncing around here. But that's what makes it a little bit more of an art form than anything else. But not only that, but as you can see, the triangles are not very neat. They're just all over the show. It can be quite messy. So we're going to use the same tools as to what I showed previously as to how we can do the retopology. So I'm going to use Control-A to select everything. I'm going to go Edit. I'm going to then say, okay, cool. Firstly, let's actually do the remesh. Because remember, with remeshing, we actually do have a reduction that can occur in the remesh as well, up to 50%. Okay, so with this, you notice that with the remesh, it's actually broken the model a little bit. This is part of the reason why I was showing you this, is that if you take a look at these sections, that's not going to be very helpful for us. So we need to actually keep our density up. So on the side, we need to go to the right. So we're going to keep our density up high, wait for the remeshing to occur. As I said, this can take a bit of time. So while we're busy waiting for this, one of the reasons why I'm not too much of a fan of always using Meshmixer, and I prefer to stay in things like Fusion 360 or, if possible, even 3ds Max, is because Meshmixer can also be a little bit twitchy sometimes. So anybody who's worked with Meshmixer but will tell you that sometimes if you look at a bit skew, it can crash or can take a while to do things. You saw how much faster the 3ds Max was to actually do its retopology. This is doing a very similar task, but it's taking a lot longer. But the thing is also, it could also be due to the triangle count. It's all very much situational based. This is taking a little bit longer than normal, but obviously because I'm busy demonstrating it for you, so it is going to take its time. It's almost done though. It should be a little bit faster from here on. Yep, 26 to 30, and now it's just doing the little polishing. Cool. So in here, patience is key. Try not to click around. Try not to do anything else. Just let it do its thing. Now, as you can see, it's done its job, but it's a very, 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 very dense mesh that we've got here. Don't worry. The next step will sort this out. I'm going to click accept. Yep, does take a little bit to get its mind around things. But we're not done yet. We're going to go edit once more, and now we're going to use the reduce. Now, this is an important step that because if you don't do this step, although it is going to make your model a little bit more inaccurate, and what I mean a little bit more inaccurate, it all depends also on how much that accuracy is really much of a problem here. But what we're aiming at is we're trying to make these triangles as large as possible, but still make the model useful. And this comes into quite a bit of relevance right now. So what we're going to do is now we are going to increase the reduction. Like I said, this, as I keep saying, this is very, very machine dependent. And while busy reducing down here, as you can see, less and less and less. And basically, we're just trying to step up. We want nice, big, large triangles for this. Almost there. What you can also do is you can go accept what's there, and then also run another reduction again. So if you wanted to, you can go reduce once more and say, okay, cool, let's step it up a little bit more. You'll notice that these ones, it'll run faster and faster because it's got less triangles to process. Now, I'm going to actually bump this up quite a bit. The reason being is I'm not too worried about the accuracy in this. I'm just more worried about as to what it's going to give us at the end. There we go. That looks good. So it's still fairly accurate. It's still around about what we want. So this may give me an issue or two looking at that. So let me reduce it a little bit less. There we go. Reason being is I'm looking at these edges over here. These little guys are going to give me gray hairs. But we'll see how it goes. I'm going to go accept. The reason why I can see it's going to give me gray hairs is the density, how close those triangles are for the next part. Now here is where the magic happens. I'm just going to hit escape, just unselect, file, let's save. Always a good idea to save. Just going to give it a new name. And what we're going to do now is we're going to click on our come on, there we go. Sorry, I'm lagging a bit my side. Going to click on our edit tool. We're going to click pattern. And once we click pattern, we've got this weird thing that happens. Now, this is don't worry, this is normal. The reason why is because at the moment the pattern is set to the default tiled tubes. You want to select it and select dual edges. And look, it's happening here. You can start seeing something very interesting occurring. It looks like what we here call chicken mesh at the moment. But if I go and I bump the element density up, I'm just dragging mine all the way to 10. Like I said, it's got a slight decimal issue here. Bump that to 10, and what's that? We've now got a Voronoi pattern. Because what it's basically doing is it's using those edges of those triangles, and it's running this pattern all across these edges. Now, you can play around with these elements, the spacing, etc., and they will do slight different changes, etc. I don't recommend this clip to surface, and just if you're getting some weird results, just watch out that this clip to surface has not accidentally been turned on. That can sometimes give you a bit of an issue. Now, this is the next part which makes this whole process a little bit of a hit and miss affair, is that when you click accept here, it's going to take a while to process this. So when you click accept, it's going to start thinking, it's going to start meshing, and it's going to start bouncing around and doing this meshing. My best advice to you here is just be very patient, let it do its thing. It is going to take a while to do this crunching and Just don't touch it. Let it do its thing. If you are encountering that it's doing this and it keeps crashing, and it keeps crashing the program and doing this, what you're going to have to do is you're going to have to work back again. Go back into the export, the original export that we did into Meshmixer, do another retopology on the surface, another reduction, and then go again. You can sometimes go back and just do another reduction or play around with the reduction sections. Because what's basically happening is it's finding too many clashing things that it can't fix in the background, and eventually it just crashes the program. So unfortunately, this can be a bit of a hit and miss affair. But once you get used to how it's running and what you need to do and what you're looking for, it can actually be quite a stable process. I think this one may be going through, but it is going to take a little while to actually crunch all of what it's trying to do. In the meantime, what I can do is show you the end result as to what it would spit out. So what I'm going to do here is I'm going to do something that I wouldn't recommend people normally do. I'm going to open up another instance. And I'm going to go open. I'm going to show you guys basically what the finished result is. Like I said, unfortunately, due to the time constraints of this demonstration, I kind of have to make an exception here. Normally, I'd like to show you the whole process, how it goes through. It may also crash the program, but yeah. Okay, so in here, I did just a quick export of one. This is actually not exactly the same. It's been played around with a little bit. But here is basically the Veranoid model of what we've been working with the whole way through. As you can see, this is not a very clean model. It's actually got a few little issues here, but those can actually be fixed. That's nothing major, but we can fix them. That's what the reason for the little bits of red in between them. So at the end, what I've shown you guys is how we can take our raw 3D scan, use Fusion 3, use a combination between Fusion 360, 3ds Max, and Autodesk Meshmixer. If you follow these things, eventually you'll get it. It just takes a little while to play around, get your ideas to how this works, what works for you, what doesn't work for you, and also the limits of your current setup. Now, that's basically everything that I've got for you today. As you can see, I'm just going to quickly scroll all the way to the end there. That's basically where I've got my slide. And last but not least, do we have any questions that may have popped up during my presentation for you? Okay, well, while you're busy thinking of your questions, just a bit of my summary that I've got here. So going through this whole process, and especially the original way I've shown you with working with the Autodesk Meshmixer and just plain old using Fusion 360, and then using the scan dots in there, to using this newer system of, well, the newer updates of 3ds Max. That new update to 3ds Max with those retopology tools was an absolute godsend, because now you can see what, just by having to manually adjust things in Fusion 360, with having to put the forms around the original mesh and then constrict it using the pull tool, you can see now as to how much of a difference that being able to take a mesh, put it into a quad mesh, upload it again, and then using that actual same mesh that we were using before. Granted, it's a little bit distorted because it's been taken from a tri-mesh to a quad mesh, but what you're still working with is far, far, far more accurate and far, far faster. I mean, I could probably do what I've shown you here in a tenth of the time that it would normally have taken. So if you've got access to 3ds Max, please go ahead, try this, do it yourself, and take a look at it. It can only benefit you. If you're wanting to use Meshmixer, by all rights, try it. Go ahead, see how it works for you. I just, like I said, I find that the it can be a little bit twitchy, and it's taking its time. As you can see, it's still busy trying to crunch on that model. I'm busy, by the way, running a Ryzen 3700X, 32 gig of RAM, Vega graphics card, and this thing still takes its time. Oh no, not the best, but still not the worst either, and it still takes its time to work with this. So otherwise, I don't see any questions that's popped up yet. Chat has been a little bit silent. But yes, if you do have any queries or anything, please don't hesitate to give us a shout. So as you probably already aware, this is Micrographics. I'm from Durban branch. There's all of our branches around the country. Feel free to get in touch with your nearest branch if you want to get hold of them, see what's going on. Otherwise, get hold of myself here in Durban. My information was right there in the beginning. So if we jump back to the very first one, Quinn Kennedy, application engineer, and there's my email address, quinn@ngfx.co.za. Otherwise, thank you very much, guys, for joining me. I hope this has been a little bit insightful. I know I jumped around quite a bit, bits and pieces of information. Otherwise, thank you. If you're watching this on the YouTube broadcast afterwards, please, if you'd like to give it a thumbs up, subscribe, and leave a comment. Thanks, guys. Have a good one. Bye.